All right, everyone, welcome back to another lab session. Today, we are going to be talking about data visualization. But before we get started with that today, I do want to point out something about your homework. So as we were just discussing, you do have homework 2 that is due tonight by midnight. And typically I have you guys submit your homework via if I can remember the words, email or Discord. If you like to use the MyHeritage website, I've been creating our assignments on the website. So you can see here online under Unit 1, it does show that homework 2 basic data analysis, that assignment that's due tonight, is available for you to submit on here if you would like. If you still want to submit it via Discord or email, that is also perfectly fine. Either way, just trying to make sure you guys have all the options possible. If you're already in the school's interface and you like to use the MyHeritage website, you are welcome to do that too. So that's just an aside. Again, I'll ask one more time. Does anyone have any questions about tonight's homework? All right, then we are going to start to dive into today's project. So today we're going to talk about an intro to data visualization. If you watched my lecture on Monday, you know that we talked about matplotlib and just creating plots and some of the basic principles behind data visualization. Well, now we're going to start to put that into practice, and that is what your homework for next week is going to be about, which again will be out tomorrow morning. So we are today going to be looking at some data on infectious diseases. Super fun, I know. And specifically in class, we're going to be talking about measles. Out of class, you will be talking about smallpox. So that'll be what your homework assignment is on is smallpox. So I found these open source data sets. They're held by a group called Virus Techo or something of that sort, but it's a large conglomeration of researchers who organize and compile data sets globally, not just in the United States. But we specifically are going to be looking at data from the United States. So this is what all of their databases are stored as, or like the format that all of their databases are stored as. So they've got the condition name, their code name for it, the pathogen name, pathogen taxon ID. So like for genetic sequencing, everything has an ID name, number of fatalities from the disease at that point in time, country name, country ISO, which is basically just what is the shortcut or the abbreviation for that country. Ours is US. Admin one name is the internalized naming procedure within a country. So like within the US, we have states. So our states each have a name. Within other countries, they have regions or districts, and that's how they name everything. So that would be these names here. Admin one ISO is the combo of both the country name and the admin name within the country. If there's a secondary name, they'll record that. In our case, we don't have that information. Scrolling over to the right, we can see we have the period start date, the period end date. So dating all the way back to I think this data set actually rolls all the way back to the 1800s, but the majority of the data starts in the early 1900s. Age range, most of them don't have that information because we weren't being that specific back in the day. Diagnostic certainty, that definitely didn't exist before maybe 1960 or 1970. Place of acquisition, if they know where they got it, they can say that. If they don't, then just is what it is. And then the source name for the data. In our instance, in the United States, we have a partially nationally funded health system that has a surveillance system. So as they're monitoring for disease outbreaks in the U.S., they record it, they update the CDC, that gets updated to our global database. And then the last column is finally the data we're actually interested in, the count values. So both of the data sets, this one that we're working on in class and your homework data set, will be in this format. So everything we practice today in class, you will be able to use to make sense of your homework assignment. And as always, our data and the notes for today's class are available on our Discord server. I just realized I forgot to upload the actual data itself. So we are going to be working with the measles data today. And the measles data is in the exact same format. I just forgot to upload it. So if anyone needs that, just let me know. We can pause real quick while this is uploading. I actually might be able to drop it in the chat too. Let's see. Where's my chat? There it is. All right, so eventually that'll load. So eventually that data set will load and you guys will be able to access it. For today, as always, we are going to start in our base terminal, work our way up through our activating our virtual environment, and then get started on our actual project for the day. Before we get there, just so everybody knows, I was having a personal issue with my keyboard macro to run line by line code in VS Code, and so was Robert. So there is a fix to that. Basically, you just have to search for the shortcut and then assign your own macro to run line by line code or your selected text. Instruction writer in the file that I sent out today for yourself. So let's get started. Let's navigate to our working environment. So I need to go desktop, teaching, SP23. Well, in there, look at, there is my virtual environment that I'm interested in, dat.sci. And I am going to activate that. The instructions to activate are over here on the left-hand side if you need them. But it's, for me, it's going to be source, dat.sci, bin, activate. All right, that is activated, and then I'm going to be working directly from my terminal. So I'm going to type in Python 3 and get Python opened up. Now, if you haven't already, make sure you download matplotlib. There's also another statistical graphing or visualization package called Seaborn. So if you want, you can install Seaborn 2, and that would just be pip install Seaborn. We do not use Seaborn today. We will probably use Seaborn here in 2, 3, 4 weeks, something like that. So as always, we need to import our packages that we're going to use today. So I'm going to import NumPy as NP. I'm going to import pandas as PD. I'm going to import specifically in matplotlib. I'm going to import a package called pyplot, which does exactly what it says. It plots figures in pi, and we're going to import that as PLT for plot. Matplotlib not found. False. Spelling error. There it is. I missed the T. There we go. Perfectly fine. Okay, now we are going to access our database or our data set that we're interested in working with today. So I am going to call on a new object called measles, and measles is going to be equal to PD for pandas, read underscore CSV. And then I am just going to type you're either going to provide the entire path, file path name to the file, or if you're in the correct directory and everything's saved in the correct place, which ours is right now, you just have to provide the name of the file because it has access to it. And I can see that my file right here up above is already in the correct directory that I'm working in. So measles.csv and our single quote, and then I need a comma, and I'm going to say header is equal to 0. So last week we were doing header equals to none. That's because we loaded our column names in separately and then combined our data sets. In this instance, header is equal to 0 because my column names are already on there and my headers are found in the 0 row. We're just going to hit enter on that. D-type warning, columns 9, 10, 16 have mixed types. Specify D-type option or import or set low memory equals false. In our instance, I am not going to worry about this warning. If we print the new object we just created called measles, you will see that it appears fine. We're going to get familiar with this data set here really quick and make sure we're okay with that warning. So we're going to go through step 1 of our data checklist here, familiarizing ourselves with the data. And to do that, we're going to call in measles head. Okay, that looks fine. Nothing weird there. We're going to go measles dot index, and we see we've started at 0. We have 436,932 total instances or observations, and they go in one increments of one, steps of one. And then we are also going to look at the measles.columns, check out what columns we have. And we've got, like we were talking about when I actually just showed you the data set directly, we've got way more information here than we want. So
Hey,
it's
Paul, I
at
have a
this
question.
point. Oh, what's up?
Do you have the measles.csv file?
It is uploading right now. Let me see how it's doing.
Oh, it's still uploading? Okay.
If you want, though, I can pause real quick, Robert, and we can come back in like 5 minutes.
No, we'll be fine.
Okay. So yeah, it's uploading to the Discord and to our chat right now. And we will see if this will actually, don't save. There we go. It's about halfway done. So this is the point. At this point, as we're familiarizing ourselves with the data set, this is the point where we kind of need to decide what questions are we trying to answer with this data. And since it's our first time doing this as a group or as a team, I came up with 3 questions. If you guys like them, we'll continue working on them. If you don't like them, we'll use different questions. So my study questions that I came up with for this measles data set are: what years were infections the worst? So like I said, we have data from I think the late 1880s all the way through 2002. That's kind of when we considered measles to be quote unquote eradicated. It never actually has been. And so they haven't been reporting as much since then. So that was my first question. My second question was, what states had the worst infections? So that kind of, to me, is more interesting. That question is more interesting from a socioeconomic perspective. Obviously, the population size based on states in the United States is extremely variable. And also the epicenters of infections can kind of be limited to the coasts. And that's because that's where the majority of our populations are. If you looked at a population map of the United States, and let's actually look at that real quick. Population map US. If we look at the map of the US based on population density, you'll see that the majority of our population is on the outskirts of the US. So on all of our coast, and California, of course, is probably our most densely populated state, and then New York is probably our second most densely populated state because of New York City. And apparently that doesn't want to load either. Let's see, data is still about halfway. So that was my second question. And then question number 3 was, after vaccine introduction, did infection rates drop significantly? And that's, of course, because we want to look at vaccine efficiency or efficacy, as well as adoption rates by the public. So these were kind of my 3 questions of interest. Are you guys interested in these, or do you have other questions you would like to add to the mix?
Can we add like a rate?
Like a infection rate per day, or what do you think?
Yeah, we could do per day.
I actually, now that our data is not set up per day, it's set up per time period. So
time period. Okay. We could do it with time periods.
With their predefined time periods.
Yes.
So we will add that and see if we get to it today. For what do we want to specifically know, Robert? Do we want to know how infection rate
within the century or the decades? Is it possible with decades?
Oh yeah, we totally can. We can summarize however we want. So how did infection rate change per decade?
Yes.
Okay. So yeah, we can add that. We will have to. So that'll be, I guess, quote unquote, more intermediate summarizing and grouping and like data manipulation, because if we look at the data format that we have right now, our years are shown in time periods as year, month, date, and they're usually a couple weeks, maybe 3 weeks, 2 weeks at a time. So they're reporting bi-monthly, and then we'll have to cut that down to just the year and then summarize a decade based on their values, like basically make a sub list to match our list and concatenate or join our list together. So it'll be a little bit of work, but we totally can do it. Anyone else have any other questions they want to add? Okay, we will start with that. And the next question, of course, we're in step one here of getting familiar with our data on our data checklist. Is anyone unfamiliar with measles or not understand what we're talking about in all of this infectious disease information? Okay. I am going to take that as a yes. We're good to go. Everyone's fine. We are all in agreement that we understand and we're familiar with the data set. So because we now have questions and we're familiar with the data, we can actually start to manipulate our data set to get rid of some of this extra information we don't really need. As I was saying, this is way more data than we have any reason to be holding on to. There's no reason we need blank columns and columns and NAs in our data set. So we're first going to start by just selecting, before we even check for structural errors in our data, we're just going to start by selecting the columns that we are specifically interested in. So I named this object, you can name it whatever you'd like. I named it measles base, and I called on the measles data set. And then I asked for all of these columns: condition name, because that's going to tell us the name of the disease, the admin one ISO, which is the US state, plus the country, the period start date, period end date, and then the count value for how many infections there were. So let's get that in there. Measles base equals measles. And then we are gonna do double square brackets, and then we're gonna name all of our names, which I'm just gonna copy and paste them to save a little bit of time here. And I forget I can't paste directly, Control-Shift-V. And close them off. There we go. That's in there. Smallpox, we don't need to worry about it right now, but notice that the columns we selected are the exact same. So now we do have the measles base data set in here, and we could call on it. Oops, not period. It is going to be underscore. There you go. So this is the format. We changed from that really long 436,932 rows by 20 columns, and we changed it down to 436,932 observations with 5 columns of data. So we've only kept the things we really need. And in actuality, now that I think about this, we can also get rid of the condition name because we're working just with the measles data. When I originally laid out this exercise, I was planning to do the measles data and the smallpox data side by side, but it's a lot to keep track of, especially when you're just starting making graphs. So we will actually go ahead and drop that column now too. So I'm just going to scroll up back to my last command, and I'm going to tab over and delete condition name and re-hit that, and now go back to measles. Measles base. There we go. All right, now we're down to 4 columns. So boom, just like that, we've totally made a massive change to our data set. It's a very small change, but it does make a difference. So now let's move on to step 2. Let's check for structural errors. So is all the data in the correct location? Does the setup make sense? Is there anything we want to move? So just looking around, we've got our observation numbers, got our US state as column 1, period start date as column 2, period end date as column 3. It looks like the start date and the end date they're actually 1 week increments. So we'd have to combine every week into a decade when we get to question 4. And then the count values are just how many ever infections they had that week based in that state. So to you guys, do you see any structural errors that we should fix at this point?
I think it looks fine.
Okay. Yeah, I agree with you, Robert. It looks just fine for what we're doing in this analysis. There's nothing we really need to work on. If we were combining data sets, if we were doing both the measles and the smallpox together, this would probably be the step where I'd go ahead and concatenate them. So I left you guys the instructions on how to do that right here. And that again is personal preference. Like if you're doing, let's say you're doing 12 diseases at once and you only want to have to do one process to get all the data ready for what analysis you're trying to do, and you want them all to show up on the same graph or figure anyways, then you would be able to add them all together right here. The only reformat I would recommend at this point in time to keep it simple for the first three questions, because if you look at the first three questions, we were asking about the years, the states, and then infection rates after vaccine introduction. For those, we don't necessarily need all of this information about period, start date, and end date. We can just make it like a year column. So we can make that small change for now. And that would help us save some space basically and simplify the computational needs to work with this data. So we're going to go ahead and do that. We're going to call it measles base, and then we're going to create a new column called year. And that new column is going to equal to P for pandas 2_date time. And that's a built-in package into pandas because they're acknowledging that you typically have to work with dates and measurements. So this is an easy thing for us to do. And then we're going to call on the measles based data set within the pandas date time function. And we're going to use our dot notation to say period end date. So I'm just picking either start date or end date, doesn't matter in this instance. And then we're going to go comma. After that, we just have to tell it what format the current columns are set up in. So you'll see we've got year, month, date. Then that's kind of like the international database style format for dates. So we're just gonna specify that in here. And then once we have this specified for the computer to know, we can make changes to that. So we're going to close that string off and hit enter. And it's giving us a warning here, not an error. So setting with copy warning, it's just telling us it's a bad idea to make a copy of a slice from a data frame. It's not really, in my opinion, 6 one way, half dozen another. It's personal preference. In my opinion, I like to have each of these data sets available the way I want to use them. So I like to store them as different objects and then iterate over an object. And then whenever I'm ready to subdivide it is when I create a new object. So in this case, we've taken and manipulated the previous data set, but that's because we're still working on something in that data set, in my opinion. So it's just personal preference. Next thing we're going to do is check on our columns. So we can make sure that year indeed did get added to our data set. So it's the very last column after count value. So now we've got that in place. We can skip this print statement unless we just want to recheck the data. Really, we can skip down to line 140 here, and we can go measles base, tell it what column we want to act on, which is our year column, close that off, equals measles base, and then we are going to specify the column again. So year, and then .dt for .date time. And then we are going to string F, which is, I believe, I think it's specifically function or time function, or it is a function, of course. I'm trying to remember what the exact word means. Let's see if it'll tell me. Let's go to references. Oh, that's not what we wanted. We want a definition, maybe. It's essentially to shift the function. So it's just saying, so up here on line 136, we told the computer what format our date was in. Down here with the strf time, we're basically providing it a function to say transition this previous format to this current format. So you can change this %y to %y dash %m if you only want the month and the year, or you could do %y %d. You can do whatever format you want, or we could, even just flip them around. So we have it year, month, date right here with this line. We could change it to month, day, year. We could change it to day, month, year. You can do whatever you want with it, really. Sorry, I can't remember the name of it. It's not super important, but we'll go ahead and throw our Y in there, close that off, and make sure that runs. Got the same setting, copy warning, because we did the same thing again. We took a data frame that it was already aware of and copied something to it in a new column. Not a big deal. Again, it's all personal preference. And this time we are going to view the data set to make sure things look okay. So we're going to go print measles base, look at it, and we are good to go. Now at this point in time, we've already significantly simplified our data set by going, we're down from 20 columns. We dropped down to 4. Now we're down to 5 because we added a column, but we also can get rid of 2 more columns now because we have our dates stored in the year format here. So we could get rid of the period start date and period end date. We can do that the same way that we just did, basically, and we can call on this same function from up here, and we could call it measles base again if we want, or we can rename it. So we'll just go with measles base, and then we're gonna select from the measles base data set because that's what we're working on. We're gonna double square bracket it, and this time we want admin 1 ISO, and we're gonna want count value, and then year. And then we just close that off. Boom, good to go. Let's double check that it actually works. So we're going to go print measles base. Perfect. Down to 3 columns. So we went from 20 to 3 now. So we've made some big changes already. I had a step in here just in case you ever need to reorder the columns. You literally just type the name of the data set or the object you're working on, and then the order that you want the columns to appear in. In this case, again, doesn't really bother me. It's just three columns. There's nothing specifically that I want to change at this point in time. If we need to, it's 1 line of code. It's not too bad. We can do it later. So that kind of takes us up through step 2. For everyone, the data set is available now. It's under February 8th, and it's just called measles.csv. And it may also have finished uploading in the chat. It hasn't finished in the chat. So I'd grab it from Discord real quick if you'd like to tag along. So that was it for step 2. Now we're going to move on to step 3, which is as simple as just checking for regular formats. So is all the data in the same type format? Or if it's not in the same format, is it in the format that we want to use for an analysis or to make our graphs and stuff? So we will go ahead and type in measles. We're going to go base.types for data types, and we'll see that admin ISO is an object, count value is an integer, and year is an object. So we could technically leave it how it is for now. That would be fine. But year is a numerical value. We are aware of that right now. And as far as the analyses we're doing for the 4 questions that we've formed, it doesn't help us in any way to have year as an object. It could potentially hurt us to have year as an object, because if you think of, we want to measure, let's go back to our questions. We want to measure what years were infections the worst, right? So that's what we would call a time series. So basically you're examining how the infection rates change over time and look year to year. So in that instance, we'd want the computer to run through the data numerically from lowest to highest. So in that case, we probably do actually want to change year from an object into year as an input. And to do that, we just need one simple line of code, and it is a little bit further down right there. On line 200, I had put it further down in the analysis because, like I said, you can do this either way. You could leave it as an object for now, or you can transition it to an integer for now at this point. So we'll go ahead and just transition it to an integer now. And I should have grabbed both of those lines. So line 199 and 200 have the code that you need. We'll just cut that out of there, come back up top, and we were under number 3 here. So we're going to convert year from an object to an integer right now. So we can just simply type measles base, and then our double brackets, select the column that we want, which is years, or year, excuse me, double close your brackets, equals measles base, double brackets of year, double or single quotation, double bracket close, dot apply. And then we're just going to ask it to apply pandas to underscore numeric, which is a built-in function to the pandas data frame. I spelled measles wrong. Right there. Measles. Perfect. And now we can go measles underscore base dot d types. And you see we've got 2 integers, 1 object. So we fixed it. We're done with number 3. I am content with the way our data is formatted, and I think it'll work for the analyses we want to do. Now we're going to move on to number 4, decide what to do with missing values. So this one, as you guys know, is as simple as measles base dot is null, and then your quotations. And you see we have false across the board here. Of course, we're not looking at every single observation, but there's 436,932 of them. So if we looked at every single observation independently, it would take a very long time, for one. And 2, we're going to trust that as Python is supposed to, if there is a true null observation in your data set, Python is supposed to provide you or how it's showing us this preview right here. Python is supposed to specifically pop up a true response if there is a true response. So assuming that our software is working correctly, I'm saying that our data is good. We do not have a missing value. And if you want, you can always scroll directly through the actual data set to make sure that is correct. All right, so we look good. We don't have any missing values. Now let's move on to number 5. Let's document any changes to the data and the project. So we're going to come back up here to the very top to our data checklist, and I'm just going to say we did some basic manipulations. And then I'm going to say we altered count from object to int. We removed 17 columns of data. Did we do anything else? I don't think so. Oh, we reformatted the year. We reformatted our date from year, month, day to year and stored it in a new, oh, that sucks, in a new column. Thought I could get it done. Is there anything I missed? All right, I'll take that as a no. We will keep going. So now we're down. We've made it through our data checklist, right? So we're good. We're comfortable. We've recorded our changes to the files. Now we're ready to jump into our actual questions about the study. So what are we trying to analyze and figure out here? And before I forget, we also added a 4th question here. Let's go ahead and copy that in just so that we don't forget that it's there. Stop that. There we go. All right, perfect. let's go ahead and jump back down here. We're going to start with the section on line 191, starting to answer questions. So our first question was, what year were infections the worst? To answer this question, we basically have to summarize the data by year and save it as a new object and then plot that object. So that's what we're going to start with. And we can look at the base data first too. So if you scroll down to line 216, I'm just going to grab this code and copy it and then move it up here to the top on line 197. And the reason for that is just so that we can walk through it real quick, because measles base is going to call from our measles base data set. So I'm going to go ahead and hit shift enter on that. And you'll see over here on the right hand side, it ran measles base.plot.line. X is to the year, so the year that the data was recorded. Y is set to the count value for that year or for that data point. Then we're going to set up a X label, and we're going to say plt.x label equals year, plt y label equals the infection, the total count. The plot title is going to say measles infections by year, and then to get the plot to actually show up, you type plot.show. So we're going to run all that. Here we go. Here's our first graph. Now, there are a bunch of things to notice here. First off, let's look at the consistency of our data. And of course, you can see that we've got a couple of issues, I would say, just in the fact that it's hard to tell what's happening here. But because this is over a long time frame, this is not surprising necessarily that our points and our graph are so small. That's something that you can fix just by stylizing the graph. So you can see in the bottom right hand corner though, that when I'm hovering over something, it shows me the X and Y coordinates or position there. So we can look at it year by year still. So I'm all the way down at the 1880s, and they had 1 infection, 2 infections. Then as we approach 1900s, they have about 100 infections. As we approach at 1908, they get, let's see, 1, 2, 3. So they get about 2,000 infections, then a little drop off. Then we have a definite peak around the 1940s when we get around 8,000 infections, a little bit of a drop off towards 1950, then an increase right before 1960, and we end up with over 10,000 infections. Another peak at 1965 with, it looks like, about 31,000 infections. 1975, we hit 52,000 infections. And then heading down, you see once we approach right after 1975, we have a significant drop off in our data. So in the early 1980s, they're only finding 500 or a couple hundred infections for the entire country for that entire year. And then we see another peak in the early 1990s, which is likely an outbreak as a result of some kind of cultural or socioeconomic factor, not as a major mutation to the virus. I could absolutely 100% be wrong about that, but that would be my first thought, is that there was something culturally happening where people either stopped getting the vaccines, or maybe we had another sort of health epidemic, which caused another outbreak. But after 1990, you see we get a drop off again. And in the early 2000s, for our last data points, we have, four infections in an entire year. So at this point in time, measles in the United States, it was a small issue. It's starting to crop back up a little bit again because people have stopped vaccinating their children for measles and smallpox, measles and mumps specifically. But so this is our first chart here. We haven't summarized anything. You can see we've got some chaos going on here in between these connecting points. And we'll try to summarize by year so we can take an actual look at the numbers here. Any questions on that plot? Okay, so we are going to go ahead and try to summarize this data by year. So we don't care what state it was in. We just want to see year to year, how bad was the US doing or how good was the US doing. So to do that, we're going to use our group by function. Group by does exactly what it says. It groups by those factors. In pandas, it's a built-in method. So we just we can subset our data set. Like I said, that's what I like to do. So in this specific case, I made a new object called measles years, which is the measles data by year. And that'll be equal to my measles base object dot group by. And then you specify what you want to group by. So I want to group by the year, and then I want my count values to be summarized, right? Because the count is our physical count of how many infections at that point in time. So actually, this is a good reference up here, right? If we look at this table, this is the format our data is currently in. And notice that we have 1, 2, 3, 4, 5 rows for one state for the same year. And that's because they were recording their observations week by week for the majority of this data set. And when that happens, of course, so if we have a full year of data, we should expect 52 data points that are going to need to be aggregated. So that's what we're doing right here is we're summarizing by those weeks. And that is also why our data kind of looks funky, is because on that first graph that we looked at, is because there's so many data points that it's probably actually reading some of them slightly incorrectly or not placing them correctly and drawing weird lines or connections between them. So we're going to try to clean that up, and then we'll try to replot the data. So we're going to start with creating our new data set, which will be measles years equals measles underscore base. And then we want to specify a group by function. So we're going to group by and then say group by the year. And outside of the year, we're going to specify, that's a bad way to say it. How I read this is that I'm just going to read it to you as I would read it once I get this typed. So I would read this as this statement that we wrote right here. I would read this as measles year, the new object, measles years is equal to the measles base data set that is grouped by the year factor or the year column with count values and then whatever your function is. So in our case, sum. So with count values summarized, okay? And I know that may be awkward to hear you say, or for you to say to yourself, but the reason I read it that way is so that I can remind myself, because it's weird to me personally with, whatever amount of programming experience I have, it's weird to me to have parentheses next to my square bracket notation. Like in a normal example, if we were trying to access multiple elements of this, like if I wanted to print just that column, I would type print and then the data set, right? And then I'd use square brackets to access a specific column. So it's weird to me to have two of the factors in your data set side by side and not inside of each other. So like for instance, the way my head works, I would expect our data set, or I would expect our notation to look something of this sort, or even something like this, where we have double square brackets on the inside, and then we have our factors separated by a comma. But that is the incorrect notation for the group by function. They need to be specified as separate units. So you have the thing that you want to group by first, and then the thing that you want to summarize or find the max of or find the average of next, shown in square brackets. And we'll run that, runs perfectly fine. Now we can print measles years, and that should pop up for us. So it's got the year over here on the left side. It's got the count value on the right side. And nothing looks out of whack. It's reading them as integers, which it should. All of them are integers. Tells me we have 115 is our length. So that means we have 115 rows of observations. 1888 to 2002. Does that make sense? Is that the right amount of time? Yes, that is the right amount of time. Yeah, that's the right amount of time. So we have for every year in our data set, we have a row to go with that, and then a total sum of how many data points or a count of how many infections occurred in that year. So now we can try to make another graph of this data. So we can simply call on measles years dot plot dot line, and then we can specify the x will equal the year, and that needs to be capitalized. And then we specify our y is still just count values, or count value, excuse me, and then we hit enter, and that worked just fine. I'm just gonna go ahead and grab this all this information from up above, because our X label, our Y label, our title, those are all going to be the same. And then the show function just pops up our data. So let's go ahead and hit enter on that. And look how much cleaner that is right there. So now we can see what our data actually truly looks like. All right, so you've and actually, you know what? Let me go ahead. I'll get rid of that one, and I will rerun this section of data right here, so it pops up another plot for us, and we can compare the two, because it's totally different. It is absolutely utterly different. This one,
I wanted to take chemistry.
It won't pop
I
up
don't know if
both.
it
I
fits
tried
in my
that.
schedule.
oh dang it! All right, so that's one of the failures here that you have to recognize is sometimes, you know, the software is only as good as the person who makes it. But anyways, you remember how jagged our image looked, and just look at how clean and clear cut this is. So what we're actually seeing on the last plot, we estimated, based on our last plot, we estimated that our total maximum infection rate was in the year 1965, and that the value of that infection rate, or that the number of infections for that year, was about 50,000. Okay, totally wrong according to what we just calculated. According to this data, in 1965, our infection rate maximized, or the maximum infection rate reached 9,342,000 people. So that is a crazy number of people infected by this one single disease. Okay, and you got to remember, at the same time of measles, we also had smallpox, we also have the yearly flu. You know, we've got other conditions going on at that point in time. And in 1965, we were still fairly young in the world of healthcare. We still, you know, we were still doing crazy things. You know, we had people on the iron lung, for instance. That was still a thing because of polio, for instance, back in the 30s. They were still using the iron lung to treat people in the 60s. So again, we've really cleaned up our data here. We see that we're fairly flat, and then we have a major peak in 1965, a drop off in the early 1970s with a couple more peaks. Then we have that final peak around 1990. Who knows what happens there? It's just another crop up of infection. And then we see we really drop off in the early 2000s. The numbers in the early 2000s, though, were even higher than what we estimated, or what I estimated. So 2002, it's got us at 2,000 infections for the year total. So, you know, we've answered number one. What year were the infections the worst? That was our first question. And the number one year right now is definitely 1965. So we've already got an answer to that question. Okay, so oh, now let's visualize this data. That is actually this part right here. And then this extra stuff, the measles years and measles sort values, that's just extra stuff in there in case you want that code for yourself later. This conversion stuff, that is also extra. So we are done with number one. Does anyone have any questions about number one?
No questions.
Awesome. Let's do number two. So what states had the worst infection rates? And actually, before we move on to number two, I hope you guys can see a pattern here of kind of how to work through these assignments, right? So the first thing we did, and I'm jumping way back, but I just want to make sure this is clear. So the first thing we did, I handed you a data set, and we checked and went through our data checklist to make sure we understood what it was. It was in a way that was usable. We formed our questions that we were going to ask about the data set, and then we started to actually answer the questions about our data set. Okay, so that's kind of an important thing for you to note is go through your data checklist, then start working on the questions. And when we started working on the questions, it's not like it took that much code. We had, let's see, 198 to 214. So we had 20 lines of code, but I put spaces all over the place. So it was really probably 15 lines of code to answer the question. And on top of that, we compared an original plot versus the correct updated plot. So again, not that much code. If you were answering the question, you would need this much space to be able to answer the question only. Okay, so I just want to point that out. And then as far as the technique we use to answer question one, all we did was summarize. We used one line of code to summarize by the year and then the count value with the count value as our factor for that year, or for each year, excuse me. And then we plotted the data based on the new data object that we just created. So now we're going to do the same thing, use a similar format, except we're going to do it by state instead of by year. So our line of code here that we need is measles underscore state. That's just what I like to name, how I like to name my objects. And then I'm gonna say that's equal to measles underscore base. And the reason for that, the reason we're using measles base still here is because that's the last set, that is the last data object that we created that is in our neutral state. So we scroll back up over here in our terminal, you'll see print measles base, and measles base was the last data set that we altered to get it in the format that we wanted to analyze it in. So we always reference back to that. Do not reference back to measles year because you'll be missing the state data. Okay, so that's just an important aside. And then we're going to go, so we're creating a new object called measles state, which is based on our base data set. And then we're going to do dot group by, and I spelled group by wrong, dot group by, and then you specify what you want to group by. So in our case, we want to do admin one ISO. And then outside of that parenthesis, you are going to put a square bracket and you're going to specify what you want it to summarize. So in our case, we want it to summarize the count value by each state. Close off your square bracket, dot sum, and go. Okay, already done. Let's look up print measles state. Oh, just a spell error. Oh, I'll get it right one of these times. There we go. Perfect. So now it's showing us every single state over all time, and exactly what's happening in each one of them. Let's see if we can notice anything interesting by eye. Texas. Texas has had over 5 million measles cases. New Jersey, 1.95 million. Michigan, 4.18 million. Massachusetts, 2.42 million. So there's a little bit of a trend there. I mean, Texas stands off on its own. That's a little interesting. But, this, looking at this data by state, and especially if we did it by year and state, we could follow or trace the infection across our time series. So that may be something that we do at a later point in time. But with this measles state data, let's go ahead and try to plot it. So we're going to go measles underscore state dot plt dot bar, and then we're going to specify our x, which is equal to admin 1 ISO, comma y is equal to count value, and close that off. Series object has no attribute plot. Maybe it needs to be plot. There we go. So that's one thing about doing it the way that I'm doing it right now, and we'll get back to the question as soon as possible, I promise. In a normal form, if you were working with a set data frame, like if you were always going to be making plots from the measles years data set, most people would specify that data set, call on that data set, create that data set, and then they would use this plt.x label format. Here, let me go to example online like this right here. So if somebody in most situations, somebody is going to create a data set or access a data set, run their analysis, create their final data set that they're interested in, and then they're just going to use matplot. So they'll just, once they have the data set up, they'll go plt dot whatever type of graph they want, and then specify the x, specify the y, specify their characteristics, and that's how they create it. Because we are saving as individual objects, you'll see that my notation is different. I put the object that I want to create my plot off of directly into the line of code. So that is not a normal syntax. That's just how my brain works. It does the same thing either way. It's a totally personal preference. For me, it's easier when I run back through the log. If I read this and go, oh, okay, so that was this. As soon as I see measles state, I know I was working on the state level data for that data set. So I hope that makes sense to everybody. If it doesn't, I'm happy to use the other notation too. So we've got our plot made. Next, we just need to specify our labels and such. So we're going to go in here and say plot X label. In this case, it is not year, it is state. Y label is infections, again, in counts. And then our title here is going to be measles infections by state, all-time record. And then we just need to tell it to show us that graph. So here is our data. It looks like a mess. Let's see, any interesting trends. So as I was saying earlier, most of our, actually that is exactly what I think I see. Let me see, where's New York? New York, oh, right there. New York's actually fairly low. Interesting. Okay, well, so I don't necessarily see an obvious trend immediately in this data. Does anyone else? It's okay if you don't. I'm just curious. Um, yeah, so it looks like our number one offenders or worst infected states are California and then Michigan. We can say Pennsylvania's up there. Texas is by far number one the worst. And then Wisconsin is also up there. So I would say those are our top four for sure: is California, Michigan, Texas, and Wisconsin. But overall, based on the question that we asked, what states had the worst infection, number of infections or infection rates? Definitely Texas. Texas is number one the worst, and by a long shot. Let's see. So the next highest is California. California had 4.46 million infections. Texas had 5.29. So I guess once we get into the millions, that's 0.8 million more. So 800,000 more infections in Texas than we found in California, which is likely significant if we did a statistical analysis on it, but it also may not be. And then so that's kind of number 3 there. We can shut that down. And I also should have pointed out to you guys, sorry I didn't say this earlier. If you look in the bottom corners here, it's got some buttons for you. So you can reset the original view. You also have forward to next, back to previous view. So you can, this plot show statement, you can use it only once. So like I could get rid of this instance and then stack all these plots together in one file and then download that file. And the save figure button is right here. It should save it, I think, automatically at 300 DPI, which is your pixel density. And that's the preferred density for like publishing figures. If it doesn't automatically say that, you just add a line into your code. So like right here, we would say comma DPI equals 300. And then that would change the pixel density for the view, which you then can save at that pixel density. So that's that. Configuring subplots, you don't need to worry about that right now. Panning and zooming, that is what it is. So that's obvious. So after number 3 is after vaccine introduction, did infection rates drop significantly? So that one I don't know off the top of my head. Let's see. When was measles vaccine invented? So Enders and his team tested their measles vaccine on a small group of children from 1958 to 1960 before beginning trials on thousands of children in New York City, and Nigeria. In 1961, it was hailed as 100% effective, and the first measles vaccine was licensed for public use in 1963. So 1963 is the year where we get a break. So let me add that down here. Vaccine introduced in 1963. Okay, so to answer this question, we basically need to look at the number of infections per year and then see if there is a significant drop off after the vaccine is introduced. And I think that makes sense. So luckily for you, for number one here, what year were the infections the worst? Well, you already got the data that you needed, right? We've got our base plot, and then we've got our updated plot with the sums by year. So we can just replot this data, pop up our chart, and then look for the data for the year 1963. So 1963, as infections were introduced, or as vaccines were introduced, that's right about here. Let's actually add a line to this. There's a cool little trick. Let's see, add vertical line to chart, Python pandas. Let's see. So again, most of the time, as I was telling you guys last week, most of the time people don't memorize these functions. You simply, you just do them when you need them, and you end up Googling them. This is apparently going to take a long time to load, but I see right here someone has using ax v line parentheses. So let's try that. Let's do plt.vlaines, there we go. And then we want to specify, so x equals 1963. And then let's close our plot and try again. Oh, I put that in the wrong place. Dang it. Let's just grab that. And I wanted it down here. All right, run that. And it doesn't look like it worked, but that's fine. We're running out of time. I'll just keep going. But anyway, so in a perfect world, vlaines is supposed to add a line to your data here. Maybe it needed instead of being read as a numeric, maybe it needed to be read as a text, but that doesn't make sense because it's in the numeric format. So I don't expect this to fix it. Yeah, it didn't fix it. Anyways, we'll keep going. So if the vaccine was introduced in 1963, we got a major spike in 1965, which I guess probably makes sense, right? If the vaccine in that little text we read, it said the vaccine was introduced in New York. Well, in our second question there, we saw that the New York data shows us that there's actually not that much of an infection taking place in New York. And I lost that data. There it is. Nope. Anyways, so after 1963, what we see is a major spike, the number one spike of the entire pandemic, or whatever you want to call it, of this entire disease. And then we have two minor spikes in the mid and late 70s, but after that, a significant drop off. So based on this data, would you guys say that after the vaccine was introduced, did the infection rates drop significantly? What do you think? And I'm asking you to answer this because this is, like I said, this will be the exact question that you get for your homework for this week. Okay, well, I'll go ahead and answer then if no one wants to answer. I would say, personally, following vaccine introduction, we have the largest spike in infections since the disease began to take hold on the US. However, after vaccine introduction, we do see a significant drop off in infections, but it takes approximately, we'll say approximately 20 years. And that I would argue is fairly accurate, right? Let's see. So if it's introduced in 1963, we really don't get a complete drop off until 1982 to 85, somewhere in there. So that's about 20 years. And then after that, we get a small peak in the 90s. But again, significant drop off after that point. So at that point, you've kind of got, like I said, I think that would be a healthcare, a US healthcare issue, like socioeconomic factor or a reason, a cultural reason people are not taking the vaccine for that 90s outbreak. So I would say yes, there was a substantial drop off. Of course, we did not quantify that today. That'll come next week when we talk about actual statistical analyses. And let's see, we've only got 7 minutes. Robert, are you okay if we do number 4 next week at the start of class? Anyone there?
Sorry, Paul, what was your question again?
I said, are you okay if we're running out of time? We've got 5 minutes left. I don't think we'll have time to do number 4 because of the data manipulation we have. Do you want to do it next week at the start of class?
This is
Yeah,
serious.
we can do that.
We've always taught it.
Okay, perfect. So that is all I had planned for you guys today. That's the end of class. Just these 3 questions is what we wanted to cover. And we started practicing how to make visualizations, data visualizations, and how to run through experiments. As I said, next week's lab will be focused on actual statistical analysis and making graphs, summary graphs again. For your homework that will be coming out tomorrow morning, you will be doing this exact same set of questions, but with a smallpox data set. So the trends will be different, but you'll be answering the same questions and using the same techniques. And I should have that out by 9 a.m. tomorrow. Does anyone have any final questions for me? Perfect. I will take that as a no. I hope you guys have a great day, an awesome weekend, and I will see you next time.
All right, Paul, have a great day.
Because the analysis course will make